Good morning, student. Today we'll start with a new chapter, that is semiconductor. It is a very important chapter. So, first, what do you mean by the electronic devices? Here, electronic devices means any device whose action is based on the control flow of electrons through it is called an electronic device. That means here we can control the flow of electron. So electronic devices are the basic building blocks of all the electronic circuits. These electronic devices are divided into two types, that is, one is vacuum tubes and another is solid state electronic devices. Vacuum tubes are like triads, dryers, but due to their several disadvantages, like they are very much low in have limited life, they have low reliability, they are bulky, consume high power. That's why they are not used nowadays. So solid state electronic devices, that is also called a semiconductor devices, are used nowadays. Now we classify the solids on the basis of their electronic properties. Like metals, which is also conductor, means a conductor, it has a low resistivity but high conductivity. Conductivity is 10 to the power 2 to 10 to the power 8. Now insulators are high resistivity or they have low conductivity. Their conductivity lies, that is 10 to the power minus 2 to 10 to the power minus 8. And semiconductor, their conductivity lies between insulator and conductor, that is their conductivity is 10 to the power 2 to 10 to the power minus 2. Semiconductor at temperature 0 Kelvin, they behave as a insulator, and if we increase the temperature, that is T not equal to 0 Kelvin, they behave as a conductor. This is a important point. So next is semiconductor. Now semiconductor are classified into several ways. First, on the basis of chemical composition, they are divided into two types. One is elemental semiconductor, another is compound semiconductors. If it is made with one single element, like with group 14 element, that is silicon and germanium, they are called as elemental semiconductor. If they are made up with more than two elements, or two elements, they are made with two elements, they are called compound semiconductor, in which they are further classified into two types. One is inorganic and another is organic. Inorganic, the CDS, gallium, arsenic, indium phosphate, etc. And in organic, it is polyaniline. Second, they are classified on the basis of nature of charge carriers. On the basis of nature of charge carrier, they are classified as intrinsic semiconductor and extrinsic semiconductor. Now, in intrinsic semiconductor means it is pure semiconductor. It is a pure semiconductor and its impurity is less than 1 party 10 to the power 10. Now, if I see the crystal structure of semiconductor, that is, if I take silicon or germanium, I know this is the group 14 elements. So group 14 elements have valency 4. Valency is 4. That means it has 4 valence electron. That means it has 4 valence electron, and this 4 valence electron will make a 4 covalent bonds. 4 valence electron, they will make 4 covalent bonds. This structure will exist only at low temperature. This structure will exist only at low temperature. Now if as the temperature increases, the thermal energy of the valence electron increases and covalent bond will break. Now if covalent bond will break, then the electrons will set free from the covalent bond and and becomes free to conduct electricity, and this electron leaves behind a vacancy in the covalent bond, and this is called the vacancy the vacancy of an electron with an effective positive charge is called your hole. So I can say that so hole is a vacancy of an electron with an effective positive electronic charge. Now as each see as each free electron creates one hole, so in an intrinsic semiconductor the number density of free electron is equal to the number density of hole, that is Na equal to Nh equal to Ni. So Ni equal to intrinsic charge carrier concentration. So we can find out the number of electrons set free at absolute temperature, that is Ne, by this formula equal to C e to the power minus Eg by twice kT, where Eg is excitation energy and K is the Boltzmann constant and C is the constant. So this is the intrinsic semiconductor. Now before we go to the extrinsic semiconductor, you have to know what is doping. So when we develop semiconductor devices with the intrinsic semiconductors, they have many limitations. We see many limitations, that is intrinsic semiconductor have low intrinsic charge carrier concentration, and so they have low electrical conductivity. The second point is as intrinsic charge carrier are always thermally generated, so flexibility is not available to control their number. And also in intrinsic semiconductor, the number of electrons is equal to the number of holes, so they cannot have predominant hole or electron conduction. And for this reason, to increase the conductivity of pure semiconductor, we have to dope with the impurity atoms. So we need doping. For this reason we need doping. The process of addition of a desirable impurity to a pure semiconductor so as to increase its conductivity is called doping. The impurity atoms added are called dopants, and the semiconductor doped with the impurity atoms are called extrinsic or doped semiconductor. Now for this doping, the essential requirements are the semiconductor material should be of very high purity, that is 99.999% or more. Dopant atom should neatly replace the semiconductor atom, and the dopant atom, that is the impurity atom, should not distort the crystal lattice.